we're going to cover, continue simplifying and combining radical expressions. Okay, so we're going to continue by adding and subtracting. Okay, so it's really similar to adding and subtracting variables. If you actually think about it. Okay, so let's say, for example, if you have 3x plus 2x equals 5x. Okay, the only way you can add them together is if they're exactly the same. You couldn't do it if one was x squared and the other one was x. They would have to be the exact same variable. It's the same thing with radicals. So if you have 3 square root of 2 plus 2 square root of 2, that's just going to be 5 square root of 2. Okay, so as long as the radical is exactly the same, you can combine them. Okay, so let's say, for example, let me make a quick note of that. As long as the radicals are exactly the same, you can combine terms. All right, so let's say, for example, if you have, let's say if you wanted to simplify 6 cube root of 2r minus 2 cube root of 2r. Okay, so as long as your radicals are exactly the same, you can combine them. So that means that 6 cube root of 2r minus 2 cube root of 2r is going to equal 6 minus 2 is 4, so 4 cube root of 2r. All right, so let's say if you have, for example, if you wanted to simplify, say 7, say times the 4th root of, let's say 15. Clean that up a little bit. Oops, here it is. Minus, let's say 3 times the cube root of 15. Okay. Even though the radicand is exactly the same, just the fact that the index is different for each one means they're not exactly the same for both. So you actually couldn't combine these two. Okay, so you cannot combine since the radicals, 4th root of 15 and cube root of 15 are not exactly the same. So your actual simplified answer will just be 7 4 through the 15 minus 3 cube root of 15. Since you can't really simplify it any more than that. All right. So any questions on that one? Okay. Leave that up for a few seconds. Excuse me. All right. Okay, so let's say, for example, if you wanted to simplify let's say the 4th root, well, maybe at the 6th root. Of 6xy minus 4 times the 6th root of 6xy. Now this one is actually a little bit different because you can tweak it just enough to make it work. Okay. Now with this one, if you notice that, let's say, oh, actually they are the same. Thought I wrote down a different one. Never mind. This is just like saying this isn't the one you have to tweak. I'll show you the one you have to tweak a little later. 6xy minus 4, 6 root of 6xy is just negative 3 6th root of 6xy. So the one coming up is the one you're going to have to tweak a little bit. Okay, so let's say for this example, if we wanted to simplify square root of 75 minus square root of 27. Okay, so for this one you will have to tweak it a little bit. Okay, so you have a square root. So the first thing you want to do is you want to somehow turn 75 and 27 into products with perfect squares. Okay. So the first thing you want to notice is that 75 is equal to 25 times 3. And 27 is actually equal to 9 times 3. Okay. We know these two, 25 and 9, are both perfect squares. Because 5 times 5 is 25, 3 times 3 is 9. So we have two perfect squares. So now we can just rewrite it. Okay, so that means square root of 75 minus square root of 27. You can write that as square root of 25 times 3 minus the square root of 9 times 3. Okay. If you remember, when you're multiplying and you have them both under the same radicand, you can separate them. So this can actually become square root of 25 times square root of 3 minus square root of 9 times square root of 3. So we know that square root of 25 is either 5 or negative 5, but we're not really dealing with the negatives, so we just use the positives for problems like this. Okay, so you have 5 times square root of 3. Square root of 9 is 3. 3 times square root of 3. And you don't really need the dot for the multiplication. Yep, so get those a little bit closer. Okay, so now you have 5 square root of 3 minus 3 square root of 3, which is 2 square root of 3. Okay, so sometimes they don't come nicely prepackaged. Sometimes you have to kind of mess with them a little bit. Okay, any questions on that one? All right. I'll leave that up for a few seconds. Okay. Okay, so let's say, for example, we'll bring that down some. We wanted to simplify. Say 18 plus 2 square root of 12 minus 3 square root of 48 plus 9. Okay. All right, so I'm just going to rewrite it just for a second. Okay. So actually the 18 and 9, we can just add those together. But for this one, we just have to notice that 12, since we have a square root, we need a perfect square. So you just have to notice that 12, if we want to look for a perfect square, could equal 4 times 3. Okay, where we have our perfect square is 4. And 48 is actually 16 times 3. Okay, where we have our perfect square in 16. Okay, so if we rewrite it, say that 5 times fast. Okay, you have 18 plus 9, which is 27, plus, instead of 2 times square root of 12, we can say 2 times square root of 4 times 3. Minus 3, and instead of square root of 48, we can make it square root of 16 times 3. And we already added those two together, so we don't need the 18 and 9 up there anymore. Okay, and just like we did before, whenever you're multiplying two factors underneath a square root sign or a root sign, you can just separate them. So you have 27 plus 2 times square root of 4 times square root of 3. Okay, minus 3 times square root of 16 times square root of 3. Okay, now once we separate them, we can just solve them individually if we can. Okay, so 27 plus 2 times square root of 2, which is 2, times square root of 3. Minus 3 times square root of 16, which is 4, times square root of 3. Okay, so that gives us 27. 2 times 2 is 4. So you have 4 times square root of 3. Minus 3 times 4 is 12. So we have 12 times square root of 3. Okay, Now we can't combine all of them, but we can combine these two. Okay, so that gives us 27 minus 8 square root of 3. Okay, so sometimes you can combine all, sometimes you can combine two, sometimes you can't combine any. So it kind of varies per problem. All right. Any questions on this one? All right. Leave that up for a few seconds. Okay. Okay, so let's say if we had an example where we wanted to simplify the cube root of 16x to the fourth excuse me, plus 4 times the cube root of 27x to the third minus x times the cube root of negative 128x. Okay, so this one gets a little bit trickier because now you have cube roots. Okay, so now when you're dealing with cube roots, you want to see if you can, if they're not already perfect cubes, you want to see if you can reduce them to factors where at least one of the factors is a perfect cube. Okay, so if we look at this one, let's say, oh, let me convert it first. Okay, so you notice that 16, you can make that 8 times 2. Because remember, 2 times 2 times 2 equals 8. So even though 16 isn't a perfect cube, 8 is. Okay, and 27, you can actually leave it because 3 times 3 times 3 is 27, so it's already a perfect cube, so you can leave that one alone. Okay, and negative 128, that's actually negative 64 times 2. Okay, and we pick negative 64 since negative 4 times negative 4 times negative 4 equals negative 64. Okay, so now we're just going to go ahead and rewrite. So instead of cube root of 16, we have cube root of 8 times 2 times x to the fourth. And we're actually going to simplify the variables too. But we're going to do that because simplifying the variables is really quick. Okay, so we're going to do that a little later. Oh, clean that up some. Okay, so plus 4 times the cube root, instead of 27, that's already a perfect cube, so we can just leave that the way it is, minus x times the cube root, instead of negative 128, we can make that negative 64 times 2 times x. All right, so just like we did before, now we have them multiplied, we can just separate them. Okay, so you have cube root of 8 times cube root of 2 times cube root of x to the fourth. plus 4 times the cube root of 27 times the cube root of x to the third. Minus x times the cube root of negative 64 times the cube root of 2 times the cube root of x. Okay, so all we did was factor our original numbers and just kind of break them apart. Okay. Now here, when you have the variables, I'm going to show you like a little bit of a trick you can use for that one. Since, let's say, x to the fourth, you can make that equal x to the third times x to the first. Sorry about that. Okay, just by the exponent rules, you're going to add those together and you'll have your same x to the fourth. That means cube root of x to the fourth can actually equal the cube root of x to the third times the cube root of x. Okay, so right now we're just kind of going through the steps of simplifying just that. Okay, so you remember, when your exponent and your index are equal, they cancel each other out. Okay, so that ends up being just x. Okay, so that's x times cube root of x. Okay, so this just becomes that. Okay, any questions on that one? Okay. So now for this one, this is actually already set up to where the index and the exponent are equal. So those two just cancel out. So cube root of x to the third, since those two cancel out, is just equal to x. Okay, so we already know this is going to equal that. Okay, and this cube root of x, it's nothing to cancel out. You can't simplify that one any more than it already is, so that stays the same. Okay, so going from where we left off here, kind of move that down a little bit, and I'll kind of separate that just a hair. Alright, so just picking up where we left off, we have our cube root of 8, which we know 2 times 2 times 2 is 8. So cube root of 8 is 2 times cube root of 2, and we know that the cube root of x to the fourth is x times cube root of x. Okay, so now we're going to work on the second term. Plus 4 times cube root of 27. We know that 3 times 3 times 3 is 27, so that just becomes 3. And we know the index and the exponent both cancel each other out. So when they cancel each other out, we're just left with x. Minus x times the cube root of negative 64, which we know negative 4 times negative 4 times negative 4 is negative 64. So that becomes negative 4. Again, times the cube root of 2. Can't reduce that one, so it stays the same. Times the cube root of x. Okay. Now remember, part of the multiplication property if you have the nth root of a times b, That's equal to the nth root of A times the nth root of B. Okay? It works the other way too. So if you're multiplying two factors, I guess you could say, with the same index, you can just combine them. So that means cube root of 2 times the cube root of x. Remember, all these are just multiplied. Cube root of 2 times cube root of x is just cube root of 2 times x. Okay, so we have 2 times x, and actually I'll put that in one last step so it's not all. You're just combining these two. Cube root of 2 times cube root of x. Okay, so plus 12x minus, well, that minus there becomes, we'll bring that up a little bit so it doesn't look like negative 4 cubed. Minus minus is positive, so you have 4x cube root of 2 times cube root of x. Okay, and because of this process, you can actually just combine those two. Okay, so that gives us 2x times cube root of 2 times cube root of x is just cube root of 2 times x. Okay, plus 12x plus 4x cube root of 2 times cube root of x, again, is cube root of 2 times x. Alright, now we can't combine all of them, but we can combine those two. Simply because their radicals are exactly the same. Okay, so we end up with 2 cube root of 2x plus 4 cube root of 2x is just 6 cube root of 2x plus 12x. Okay, so that would be your final simplified answer. All right, any, yes?
Wouldn't it be 6x for the final answer?
Oh, 6x, thank you. X cube root of 2x. I was just testing you. All right, any questions on this one? All right. Leave that up there for a few seconds. All right. Okay, so let's say, for example, if we wanted to simplify, say 5/6 times the square root of 45x to the 4th plus 2 times the square root of 20x to the 4th. Okay, and I'll give you a few minutes to start on that one. Okay, I'll give you a quick hint just to get you started. Remember, 45 is equal to 9 times 5, and 20 is equal to 4 times 5. Bless you. So that'll get you started.